Hello everyone, welcome back to my channel. In this video I'm going to be talking about electron configuration. Let's say we have a sodium atom with 11 electrons, and this can be written as 2, 8, 1 if we look at the electron shells. So this basically tells us that the first electron shell contains 2 electrons, the second electron shell contains 8 electrons, and the third electron shell contains 1 electron. The number of electron shell is related to how far away it is from the nucleus, so this will be the closest, followed by the 8, followed by the 1. If we are to use a magnifying glass and we zoom in to these subshells, we zoom into these shells, electron shells, what we will see is subshells. Subshells, and there are 4 types of them. There's an S subshell, P subshell, D subshell, and F subshell. Due to the nature of this video being aimed at beginners, we're not going to be focusing on the F subshell. Instead, we will just look at the S, P, and D. Now, the way this works is each subshell contains orbitals, and orbitals, you can think of them as a square box which contains 2 electrons. It's important that the 2 electrons are not facing the same direction. This is because due to the repulsive nature of electrons, they would want to repel, and they would prefer to be facing in opposite directions in order to minimize the amount of repulsion that can happen. And the S subshell contains 1 orbital, and this means it can hold a total of 2 electrons. Meanwhile, the P subshell has 3 orbitals and can hold a total of 6 electrons. The D subshell can hold 5 orbitals and can hold 10 electrons. And the way it works is we have the nth number, which refers to which subshell we are talking about. And the first subshell will be the S subshell, which can hold a total of 2 electrons, which we call 1s, followed by the 2s orbital, and then the 2p orbital, and then 3s orbital, 3p orbital, and then the 3d orbital, and so on. Now, if we look at the electrons, the maximum amount of electrons that can be held, so in the first shell we can hold a maximum of 2 electrons, which correlates with the first shell which we saw here, which can hold a maximum of 2. And the second shell, we can see that the s orbital can hold 2 electrons and the p orbital can hold 6 electrons, which is in accordance to a maxed out shell which has 8 electrons. And then the third shell has 1 electron, which we would add here. And there you go. So if we were to write the electron configuration, we would write it as 1s2, 2s2, 2p6, 3s1. And it's crucial to understand that electrons are filled in the order that is shown here, because it's due to the nature of the electrons and how much energy they have. And the s orbital always gets filled first, followed by the p orbital, followed by the d orbital. However, there are a few exceptions, and I will probably make some future videos talking about them, especially when you look at transition metals. But this is the basic concept and the basic overview of how it works. If we were to look at the shapes, the s orbital is a round sphere. A p orbital is a dumbbell shape, and there are 3 p orbitals that exist. Which is, one is in the xy plane, one is in the xz plane, and one is in the yz plane. And then d orbital gets, after p it becomes a bit complicated, and you have loads of different orbitals present. However, we're not going to be going too in depth about the d orbitals, so don't worry too much about it. Thank you for watching.